In our first loan example, we used a nice monthly payment of $200. It was just convenient to have the 200 as a nice even number to work with to show how each monthly payment first pays off the interest before anything left over pays the principal. But most lending organizations will set up loans to be paid back in a certain number of years, not a nice monthly payment. That's a whole number. What they're going to do is set up the regular payment in an amount that will guarantee that you complete the loan within a certain time period. That we call that time period for the loan term. With car loans, it's really common to have 4 or 5 years. With home loans, really common lengths of a loan would be 15 or 30 years, but you could certainly have 20 or 10. But 15 and 30 are probably the most common. And again, with car loans, 3 or 5 are really common. Now, to work out that exact amount to pay each month so that the principal and the interest is paid off in an exact amount of time, exactly 4 years or exactly 5 years or exactly 15 or exactly 30, you need a pretty complicated equation. But we're going to kind of go a slightly different route. We're going to use a spreadsheet to actually work out the payment for a regular time period. It turns out it's a formula that's pretty straightforward, and you can use it in any spreadsheet. Excel uses the same formula that Google Sheets uses, that the similar spreadsheet for Apple devices use. It's called the payment formula. And one thing about working with formulas in spreadsheets is you always have to start with an equals. It is essential that you put the equals first, not midway through the formula, but first, because that's the clue to the spreadsheet that you're starting a calculation. This is a payment formula, so the abbreviation in the spreadsheet is PMT for payment. And what we're going to put in is the information about the loan. The information that the formula that you absolutely need for the formula is the rate, the number of periods, the present value, and the future value. Now, there is one other entry called end or beginning, which has to do with whether you are paying off the loan at the end of a month or at the beginning of the month. We're always going to be doing the end, and that's the actual default in all spreadsheets. So we actually don't have to enter anything in there if we're using the default. But I threw it in just in case you happen to see it come up as a prompt in the spreadsheet, so that you wouldn't be confused by it. But you can just leave it off. Now I do want to go back and mention something about the rate and the number of periods and the present value and future value and what each of these means. Now the rate is actually the rate for every time you make a payment. So remember how with that loan we did earlier, we had to convert the annual interest rate to a monthly rate. Well, that's what we're going to do every time here. This rate is actually going to be the annual rate divided by how many times you make a payment each year. N is often referred to as the number of compoundings. Number of periods, again, that actually means how many times we actually make payments. So periods refers to payments. So that would be N times a year. So for instance, 12 times a year or monthly, that would be 12 times, and I'm going to use an asterisk in a spreadsheet for times, the number of years, so T. The present value is the loan amount, and the future value is 0 because you actually don't want to owe anything by the end of the loan. So let's look at the example we just had. Let's say you want to borrow $10,000 to buy a car. The annual interest rate is 5.5%. Now, when I was using a $200 payment, we paid off the loan in about 57 months, which is between 4 years and 5 years, right? If it were 48 months, it would be exactly 4 years. If it had been 60 months, it would have been exactly 5 years. So when we used that $200, it gave me, we ended up having to pay somewhere between 4 or 5 years. Let's say we wanted to exactly pay off the loan in 4 years. We can use this payment formula, say equals PMT, to work out what the monthly payment would need to be. Now we're going to put the rate in. Remember, the rate is the annual interest rate divided by how many times a year you actually make the payment. We're making monthly payments, so that would be 12 times a year. So we take 0.055 divided by 12, and the slash in a spreadsheet is a divided by. And you let the spreadsheet calculate it. Don't worry about doing that ahead of time, just put it in exactly like that. Then we're going to put in the number of periods, which represents how many times we make payments. When we're making payments 12 times a year for 4 years. So I say 12 times 4. You could put a 48 in there, but I'm just letting the spreadsheet calculate it. Again, the asterisk represents times in spreadsheets. Comma, the next thing would be the loan amount. That's what present value means, 10,000. Now be careful when you enter 10,000. Sometimes, especially because we tend to write them in words with the comma, a big number with a comma, you might be tempted to put a comma here in the 10,000. Do not put a comma there. The spreadsheet will interpret that comma not as being the 10,000, but it will interpret it as meaning that you're going on to the next value. And then we want the loan to be paid down to 0. Remember, the last entry we can ignore, so we close our parentheses and hit enter in the spreadsheet, and this will return a value that will be the monthly value, the monthly payment. And in fact, it comes out to be $232.56. Now, if we think about that answer, remember, if we paid $200 each month, it took us 57 months to pay off the loan. So it makes sense that if we want to pay it off in 48 months, we'd have to pay a little bit more each month. And there we're seeing a little bit more each month. $232.56 is a little more than 200. So that makes sense. Now let me go ahead and show you what this would look like with the spreadsheet. Here I have Google Sheets open, and I have a reminder here that we're dealing with a $10,000 loan that we want to pay off monthly for 4 years at 5.5% annual percentage rate. All right, so to put any kind of calculation into a spreadsheet, you always start with equals. So put your equals in there. The formula we're using here is the payment formula. It stands for PMT, and you'll notice a little prompt there from Google Sheets. Start with a parentheses, and then the first entry is the rate. Now this is related to the yearly rate, but it is the rate for every time you're making a payment. So the yearly rate is 0.055, always write the rate as a decimal. But if we want it to be related to when we're making the payment, it needs to be a monthly rate. So we divide by 12 to make it a monthly rate. So the rate has to be related to when you're making the payment, comma, the next entry is the number of periods, which is another way of saying number of payments in all. Now we're making payments every month, so that's 12 times over the course of every year, and we're going out 4 years. So 12 times 4, that's 48 payments, but I'm just gonna let the Google Sheets calculate that, so I have an asterisk to say 12 times 4, comma. The next entry is present value, which is the value of the loan at the beginning, $10,000. Don't use a comma in that 10,000 or Google Sheets will totally not be happy and give you the wrong answer. And then the final entry is that we want the loan in the future to be down to 0. So future value with loans is going to be 0 because we want to pay it off. Close your parentheses and hit enter. And the value that Google Sheets gives you is the monthly payment. We're going to be paying $232.56 every month. Now, notice it's negative. We don't really have to report the negative Google Sheets because it's wanting to think about how that is a payment, that it's going out of your account. So it's technically a negative. But if we were just talking about this and putting it as an answer, we would just say the monthly payment is $232.56. We wouldn't use the negative in our answer. One thing you can do if you want to go back and double check your formula is you can double click on the cell where you had that number. It'll bring up the formula again so you can see it and make edits if you realized, oh, maybe in another problem you wanted to do something else or you accidentally made a mistake and put the wrong interest rate in. For instance, it's very easy to lose a 0 when you're putting interest rates in. Whoops. I meant to do take out the 0, not the 5. So what if you had accidentally left out the 0 there? This would be a 55% interest rate. Look at how much your payment is with 55%. It's $518 a month. That's a lot different than what it should have been, which is, again, $232.56 a month. So it's handy to double check that you've entered everything in correctly a couple of times before you accept an answer.